Good morning, good evening, good afternoon. My name is Efremkin. I'm a software engineer at IBM in Linux on Z workload enablement team. And today I would like to present you our open source solution, Tessia. When you want to run some workload on a Linux on Z, installation of a distribution is something you cannot really avoid. And Tessia, which stands for Task Execution Supporter and System Installation Assistant, is about making that happen a lot. It automates installation-related tasks, helps managing the resources involved, and provides a command line interface and a REST API to be used in other toolchains. However, we need to make certain provisions for an installation, whether it is manual or automatic, and there are three key components, and those are not specific to Z, they can be found at cloud providers as well. And non-volatile storage, that is where the files are placed, a network to communicate with the system, and a virtualization method and its respective choice of a controlling entity, also known as the hypervisor. Tessia supports installation on DASD and SCSI disks. Network is usually provided via OSU cards, but hypersockets and working cards are also supported. There is also more than one virtualization method. A Linux on Z can be run on LPAR, which is as close to bare metal as it can get. It can be run in a ZVM guest, or it can be run in a KVM guest. Tessia supports all of these too. With rare exceptions, a ZBox is used by many people, and there are hundreds of guests in just one box and thousands of volumes in just one storage server. So it would be best if we put all available resources into a database. Say we have a ZBox called here CPC1. It will be the hypervisor for all LPARs that we define further. On the right, you can see a command line that can be used to define one. An LPAR can be added to run Linux as it is, or it can run a ZVM instance, or it can be used as a KVM host. We add further ZVM guests by setting their type to ZVM and specifying a respective hypervisor, and likewise for KVM. For storage, we define a storage server and all the volumes are then added within it. A volume type can be a DASD or an HPAF alias. They have the simplest configuration, but they are Z-specific. SCSI volumes, on the other hand, should contain path information, such as the FCP device in use and worldwide port number. A network is separated into zones, which are a collection of subnets. Subnets have standard IP configuration and contain IP addresses to be used by systems. Finally, we get everything together and combine resources into a system profile. A system profile defines how much memory and CPUs do we want to use, what are the network interfaces and device-specific configuration for them, what are the volumes that we want to use. And one question that is often asked by installers is the partitioning scheme on the volumes. We are almost done configuring the hardware part, but we have not decided on what are we going to install yet. Officially supported for Z are Red Hat Enterprise Linux, SUSE Linux Enterprise Server, and Ubuntu distributions. Tessia comes with installation templates for all of these, starting from RHEL 7/12 and Ubuntu 16. It is of course possible to add your own installation template, and so Tessia also comes with a Fedora. However, Tessia does not provide any repositories. The best way to obtain a repository would be to get an ISO image from a distribution partner. Mount the ISO image to a directory and then publish this directory via a web server so that Tessia could access it. Then only one command is needed to register the repository within Tessia. And now we can proceed with the automatic installations. Tessia performs automated installations using a feature of nearly all distros, the unattended installation. Using data from the database, Tessia generates a configuration file, whether it is a kickstart or an autoyast or a pre-seed, and then boots the installer with it. The biggest difference, apart from different distros having different configuration files, comes from the choice of the hypervisor. For example, on ZVM, Tessia connects with the ZVM hypervisor using the 3270 protocol. It then checks the attached hardware and downloads kernel and initial RAM disk from the repository to the guest's reader. It also supplies an installer kernel command line. The guest is then IPL'd from the reader, and installation is started in the automatic mode, to which then Tessia provides the configuration file from the template. On an LPAR, situation is somewhat different. Tessia communicates with the HMC using HMC API, and then it updates the activation profile of the system to specify the correct amount of CPUs and memory. Now, normally, when you install Linux on an LPAR, you boot it from a removable media, such as a DVD or a remote FTP server. However, such facilities for Tessia are unavailable, and to work around that, Tessia provides a pre-installer image. So the LPAR is loaded from the pre-installer image, which then downloads the kernel and the initial RAM disk from the repository and provides a corresponding kernel command line. Then the pre-installer image kexecs into the installation kernel, and then it starts in the automatic mode and downloads the rest of the configuration from Tessia server. For KVM, Tessia connects to the KVM host directly using SSH and creates various definitions for the guest. Guest is starting using the remote kernel and initial RAM disk as specified in the repository. The installation is started automatically, and the rest of the configuration is retrieved from Tessia server. Once an installation process is started, it takes a few minutes to complete. Tessia stores the output log and displays all the steps it takes to get the system up and running. Automated installations could be difficult to perform on scale without a resource management system. Also, you wouldn't want to reinstall a live production system or erase available disk. So Tessia implements a resource access control. All resources can be assigned to different projects and distributed between the users. The users may have a varying degree of access to the resources depending on their role in the projects. This helps keep track of who owns what and doubles as a safeguard against mistakes. On top of that, Tessia lets you run an Ansible playbook on the installed systems. Here is a simplified example of a parameter file that lets you do that. Ansible playbook may be located in a Git repository, and the entry point and systems and their groups are all listed in the parameter file. Once a playbook is started, Tessia records it as a job and it is executed in the background. All the output is stored just like as in auto installation. But there is more than that. Tessia exposes a REST API interface which opens up limitless possibilities to consume it. So provisioning a Linux on this system in a desired configuration could be a part of an existing pipeline. And by the way, command line interface also uses REST API, so it can be installed separately to connect to a remote Tessia server. And of course, nothing is stopping from plugging in a web interface, which could make self-provisioning of a Linux on the system as simple as that. Tessia is being used internally in multiple projects and several continuous integration systems. I invite you to take a look at Tessia documentation and try it out for yourself. Feel free to open up pull requests or issues in Git and reach out to us directly if you have any questions or suggestions. Thank you very much for your attention and have a nice day.